Alright, let's do this engine repair 2 test 11 now. And I've actually got a, this is a fouled up verbiage under there where I made the test and all. This is engine condition diagnosis and in-vehicle service is a chapter on that. That's not the right chapter that's listed up there, so don't get confused by that. Technician A says a paper test could detect a burned valve. Technician B says a grayish-white stain on the engine could be a coolant leak. How many of you guys have seen a grayish-white stain lately? Did you see a grayish-white stain lately?
Yeah.
Where?
Water pump.
On the water pump, right? That was a coolant leak. And okay, and so you've also got the paper test. What's a paper test? Anybody know what a paper test is? If you hold it at the tailpipe and it tries to suck it back up into the tailpipe, you know, that's the old standard for a burned valve test, obviously. Now, why would it be trying to suck it back up in there? And what's that got to do with a burned valve? You think about that? You got a burned exhaust valve. It's not seating. Piston goes down, trying to pull air in the exhaust, right? Basically. Now, if you're just holding the paper down there and it's misfiring, it'll go poof, 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 poof. It won't usually try to suck it back up in there. There's a fine line between that. There's other ways to do that that's better than that. Two technicians are discussing oil leaks. Technician A says an oil leak can be found using a fluorescent dye in the oil with a black light to check for leaks. Who in here has done that? We've done it, haven't we? We do that. That's as good a way as there is. Technician B says a white spray powder can be used to locate oil leaks. That's the Dr. Scholl's foot powder. You just paint everything snowy white with the foot powder, and that black oil is going to, where it's coming from, is going to show up really fast. And what I probably would do is wash it down with brake parts cleaner and then spray it with the foot powder, and you can see where that oil is coming from, because it gives you a different thing. My son Luke had this, went to this place over there, a shop over in Augusta, or close to Augusta where he lives, and they put an oil pan gasket on his Toyota Camry. Because when they make a trip, load all 3 boys in there, they come on a little 98 Camry, and they charged him like $400 to put an oil pan gasket on it. And so, because he had a leak, it was fairly serious. So about halfway over here, he was noticing that he was always checking his oil, and he was seeing oil everywhere, and about every 100 miles, he'd have to put a quart of oil in it. It was terrible. And so on those Toyotas, that little triangular shaped oil pump has got a little O-ring that's shaped like it. And that oil pump is down there, you know, on the engine to the left of the crankshaft and just above it. And the timing belt actually drives the oil pump. I got one of those oil pumps up there. And it leaked oil right there. And it was basically come down from above, running around where the gasket was. And you'd think from the way it was leaking that the oil pan gasket was leaking. But we had to put an oil pump gasket on it. Not oil pump gasket, not oil pan gasket. Anyway, they were a stand-up deal, though, because I took pictures of it, and he took the pictures back and showed it to him, and they actually gave him his money back for the repair where they put the pan gasket on it, which was really a stand-up bunch of folks, you know. Which of the following is least likely to cause an engine noise? Cracked exhaust manifold, vacuum leak, carbon on the pistons, loose accessory drive belt. Who knows?
I want to say carbon on the pistons.
Well, carbon on the pistons will increase the compression and cause it to knock.
Also cracked manifold.
Cracked manifold will make a noise that, you know, starts out like an exhaust leak, and then whenever the manifold swells up and the crack goes together, the exhaust leak goes away. Cracked manifolds on a cast iron exhaust manifolds crack very regularly. That causes a leak. What about a vacuum leak? You're not typically going to get anything. You may have it running rough. You may hear a little shh noise or something like that, but that's the least likely to cause an engine noise. Loose accessory drive belt. I tell you something. When I was working at that shop back in Ed Davis's shop back in 1977. There was a Ford pickup that came in there, and you'd swear that motor was coming all to pieces. It was like a 78 model or something. Or I mean, not a 78, it was like a 68 model. It was about 10 years old at the time. And it was just knocking up a storm, just making a horrible racket. And I said, golly, that thing sounds like it needs an engine. And it had the old V-belts on it, you know. And so what he did was he took his pocket knife out and he cut the belts off of it and told him to start it back up, and it made no noise at all. And it was those belts that was making it make that noise. And you swear it was an engine knock. It was terrible. Serpentine belts won't do that. But the serpentine belts, like the one I showed you, will make them whine and make you think you got a bad bearing. If you got them shiny serpentine belts that look kind of like a gator back, they'll make a noise that's really nasty. even when there's nothing else wrong, but the belt should be changed. So belt can make it do it too, you know, carbon on the pistons. And the way you get carbon off the pistons, what we used to do, every now and then we'd come in with a carbon knock, and you can kind of tell that's what it is, you know, if you get used to listening to a few of them. We'd pour a bunch of Type F transmission fluid down in the intake and get it, soften that carbon up, and then we'd follow, you know, revving it up. When you pour it in there, it smokes up the parking lot. You got to go outside to do it. And then you follow up with cold water, pour it in there while it's running, and of course it sputters and pops and cuts up, but it cleans that carbon off the pistons, and it will stop that knock if that's what it is. A good engine should produce how much compression during a running dynamic compression test at idle? You notice I got a running compression test worksheet here that I got for you guys.
60 to 90?
100 to 150.
No, we're talking a running compression test, right? And 60 to 90 is correct because it's going to be about half of what your static compression test is. Like if you're just spinning it over, but if you put your compression gauge in there and you crank the engine with a compression gauge in there and let it run fire on all the other cylinders, it's going to be about half of what healthy compression is. Now remember this is important. A overhead valve, which is the one with the push rod, a push rod engine, is going to have usually about 160 pounds per cylinder if it's healthy. They need to be pretty even. An overhead cam engine, or one with multiple valves, will usually have more than that, like 175 to 180. And so you're going to have more compression on one of those than you are. Just keep that in mind, you know, just as a standard rule of thumb. A smoothly operating engine depends on number 5. Equal compression between cylinders is really good. There's another little thing I'd like to talk about in engine repair. There was this Mustang that was had a misfire code that kept coming back on cylinder number 2 or whatever it was. It was a late model Mustang, like with a dual overhead cam, you know, V8 in it, one of them fancy, maybe a Saline, I don't remember. But anyway, there's a handout that I usually give out with a picture and all. But I noticed that the compression was 40 pounds per square inch less on the cylinder that was throwing the misfire code, right? 40 psi. And they also noticed on the IDS power balance, they were getting about a 40 RPM drop. But then when you let off the gas, it would go 40 RPM higher than the rest of the cylinders. And what the deal was there was that when they pulled it apart, they turned the engine over and they're watching the pistons come up. And that piston, when it came up a 1/4 of an inch less than the pistons next to it, because somehow, at some point, some water had gone in, possibly through the breather. I don't know. Maybe they went through the drink, and it hydraulic locked on the way up, and it bent that valve that rod just a little bit. And it wasn't making any noise. The only symptom they had was a misfire code on that cylinder. I think it was a P0302, something like that. But I even got a picture of the rod. It was perfectly bent. They just had to put another rod in there, you know. But anyway, 40. You couldn't feel it miss, but the engine controller was picking up that 40 RPM less on that particular engine. And the criteria is going to be different from one engine to another. A good reading for cylinder leakage test would be what?
D.
Yeah, all cylinders below 20% leakage is good. And you know, you got the cylinder leakage tester. We got that. There was a worksheet I passed that on that earlier where you do cylinder leakage test. And you know, we could have actually done that on this one that you guys are pulling the head off of. We knew good and doggone well that cylinder didn't have any, you know. And it's coming down. Whenever you hold a gas pedal down, you're spinning it over and you hear it going through the intake. You know it's going past the intake valve into the intake. I'll be interested to look at that when we get it off. Technician A says during a power balance test, the cylinder that causes the biggest RPM drop is the weak cylinder. Now, that's not true. Remember when we were doing a power balance test on that truck, I was pulling the plug wires, and when I pulled the one, you know, our ace misfire detective told us that number 4 was the misfiring cylinder. And so to verify that, with it running, I pulled the plug wire off and it didn't make any difference at all. So that's basically what your power balance is about. Technician B says if one spark plug wire is grounded out and the engine speed does not drop, a weak or dead cylinder is indicated. That is B, number 7. All right,
What was 5?
Huh?
What was 5?
B.
Anybody else got any questions about number 5? Equal compression between cylinders. Makes sense, doesn't it? Engine cranking vacuum should be what? In other words, you hook your vacuum gauge up, you spin it over. How much should it be sucking on that manifold when you're spinning it over? You got any idea?
17 to 21.
2.5 high or higher spinning, not running. Running is good for 1721, is good running, but cranking vacuum is not turning this fast. 2.5 inches or higher. If you got much lower than 2 inches, you got some kind of an issue there. Technician A, this is on verse 9, excuse me, verse 9. Number 9, Technician A says a leaking head gasket can be tested by using a chemical tester. Now we've got a chemical tester in here that we're required to have for an ATEF. Technician B says a leaking head gasket can be found using exhaust gas analyzer. Well, that's kind of dumb, because a leaking head gasket can be tested for by using a chemical tester. And you can use an exhaust gas analyzer too. How would you use an exhaust gas analyzer? I'm going to take that sniffer from that exhaust gas analyzer, and I'm going to take the radiator cap off while it's running, and I'm going to hold it in there and see if it's picking up any exhaust fumes, right? Hydrocarbons, whatnot. If it does. But see, this is something I'm kind of confused about here, because according to the answer key that the book publisher put out, 9 is supposed to be B. Now, she grades these tests meticulously, even though we go over them in class. So make sure you put B down there so she doesn't mark it wrong. But I don't like B. I don't think B is a good answer for that. Low oil pressure warning light usually comes on when?
Is it D?
It's actually C, when the oil pressure drops dangerously low, 4 to 7 psi. I was working on a Dodge pickup that wasn't really all that old that we had at the company I worked for in Texas. And I noticed that the oil light was flickering on. I wasn't hearing engine noise and all that. And so I put a manual gauge on it and told them to keep an eye on it and all that kind of thing. And they drove it for another couple of weeks. And then the engine just cratered beside the road up there. I dragged the truck back in there and took it apart, and the crankshaft had broke. The crankshaft was cracked, and oil pressure was coming out of the gallery that's drilled through there. And I put a different engine in it. But I mean, the crankshaft, when a crankshaft breaks, it's really pretty traumatic, you know. The water pump can fail to provide the proper amount of coolant flow through the coolant system if what has happened? A, the coolant is leaking from the weep hole. That's not true. B, the impeller blades are worn or slipping on the shaft. That's true. C, the bearing is noisy. A bearing failure has caused the shaft to become loose. Well, see, I don't really like that either, because they've got a couple of answers here that I might think was right. If I was taking this on an SAE, I would test, like an ASE test, I would have issues with that. But the impeller blades are worn or slipping on the shaft. Now, the impeller blades will slip on the shaft on a water pump. You see those little water pumps with the plastic impellers over there? Those are the kind that can slip on the shaft. They've got aluminum bushing that's pressed on that shaft with a plastic impeller on it. I've seen those slip on the shaft. This one guy had a van that he was working on. Couldn't figure out why it was overheating. He'd done everything he could think of. And when I pull a water pump off, you could grab that impeller and just spin it with your fingers on the shaft, and it wasn't moving the air. If it's rusted, there's a rusty oil pump over there. Pick up that, water pump. Pick up that water pump on the far left. Pick it up. Flip it over. Look at the impeller. The impeller on that water pump is rusted away to the point to where it's got a lot of space between the reaction surface and the impeller on that pump. That came from a Taurus. Believe it or not, it wasn't overheating. It came in here because the heater wasn't working. And when we took the heater hoses loose from the heater core, looped them out with a clear piece of hose, cranked it up, there was no coolant flowing through that heater core because of that bad water pump. If your coolant is not flowing through the heater core, then you need to you're either low on coolant or water pump's not moving it. Let me see. Intake manifold gaskets on a V-type engine can fail due to what factor? Coolant damage, fretting, relative movement between the intake manifold and the cylinder head. That's all of the above. Why do you have relative movement? What about cast iron cylinder heads and aluminum intake expand and contract at different rates, and they totally scrub the gasket away, right?
What's fretting? What is fretting?
Fretting has got to do with some of the little chunks of it getting gone. That's the way I always see that, Yeah, it's like it's kind of like losing material until it doesn't seal anymore. That's what fretting would be. That's in my mind. I don't know what somebody else might call fretting, but every time I see fretting, that's what I think about. It's just losing little chunks of gasket, you know, as it melts away. And then coolant damage. A defective thermostat can cause the powertrain control module to set what diagnostic trouble code?
B.
Yeah, that's a P0128 or a P0125. If either one of those codes can be a thermostat, or, you know, is a thermostat every time. If you get a P0128, you may as well throw a thermostat at it. That's about all there is to it. If you look in the book, if it says P0128, it'll say replace thermostat. Of course, a bad coolant sensor could technically cause that, but not in one time in 1,000. A replacement plastic intake manifold may have a different design or appearance from the original factory installed part. You've seen that before, hadn't you?
Yeah.
That is an A. Torque specification for many plastic intake manifolds is in what unit?
Pound inches.
Yeah, inch pounds, and we have seen that. So when replacing a timing belt, many experts and vehicle manufacturers recommend that what other parts be replaced? All of the above. Camshaft oil seal, tensioner assembly, water pump, whatever is being spun by that timing belt. And you know, and anytime you got it off there, always spin the pulleys, fill the water pump. You know, any belts you're taking off, even if it's not a timing belt, feel of everything that spins with that belt, because you will be surprised at the noisy stuff, the loose stuff you'll find. It's what's terrible is if you don't do that and it locks up and it comes back, you know, it's like something you should have caught. You don't want to have that going around. Hybrid electric vehicles usually require special engine oil of what viscosity?
0.20.
0.20, but believe it or not, Kevin McCartney was teaching a class on motor oil, and he's pretty sharp on that. He said that 0W20 is a thicker oil than 5W20. It doesn't make any sense that it would be, but you know, it is what he was saying. And I mean, I always remembered that. Technician A says uses a steel gasket scraper on aluminum engine parts. Technician B uses a plastic or wood scraper on aluminum engine parts. You know, this is something that they're always saying, use a plastic scraper on aluminum engine part. They're afraid you're going to take a razor blade and gouge a place in the aluminum and ruin the part so they won't seal anymore. I don't know of a single mechanic that I have personally known that doesn't just use whatever they decide to use and be really careful. You know what I mean? Just be careful. Don't use the green bristle disc on aluminum, or you will take some material away, though, if you're going to use the 3M thing. All right. Let's see. On some engines equipped with a timing belt, the belt may also drive what?
The water pump.
Yeah, and that's true on timing chains too. The 2.7 liter engine has got the water pump driven by the dadgum timing chain.
What was 12, 17, and 18?
My goodness, where were you, boy?
17 B.
18 is B, 12 is D.
All right, anything else? Let's go to lunch and we'll resume when we get back.